Hello everyone, and welcome to this explainer of Chapter 25 from our software engineering text. Today, we're stepping into the lecture hall to tackle a subject that forms the absolute backbone of professional software development. We're talking about configuration management. I am so thrilled to guide you through this material today. Think of me as your lecturer, here to help you deeply understand the policies, processes, and tools that keep massive software projects from, well, falling into total chaos. So, grab a coffee, get settled in, and let's prepare to master this absolutely vital chapter together.
To start us off, I want you to think about a highly relatable scenario. Have you ever accidentally overwritten a colleague's code? Or perhaps you've been working on a university project and just completely lost track of which version of a file was actually the final one. You know exactly what I mean, right? You end up with files named Final, Final v2, Actual Real Final I Promise. Now, I want you to imagine that exact chaos, but scaled up to a team of hundreds of developers, all working simultaneously on a multi-million-dollar software program. Unmanaged software change inevitably leads to disastrous overwrites, lost work, and completely unpredictable system behavior. And that is exactly the nightmare we are learning to avoid today.
So, here is our roadmap for today. 1. An introduction to configuration management. 2. The 4 core activities. 3. Phases of system development. 4. Essential CM terminology. And finally, 5. A summary and exam review.
Let's jump right into Section 1, Intro to Configuration Management.
Okay, let's nail down a foundational understanding of what configuration management, or CM for short, actually is. By definition, configuration management is the set of policies, processes, and tools for managing changing software systems. You see, software is literally never static. Change happens all the time. New versions implement proposals for change, they correct faults, or they adapt the program for different hardware. If you don't manage this constantly evolving behavior properly, it becomes incredibly easy to lose track of what changes and which component versions have actually been incorporated into your system. It's like trying to put together a giant puzzle where the pieces keep changing shape.
So, the absolutely crucial question is, why is this so essential? Well, without effective CM procedures, you might waste precious hours modifying the completely wrong version of a system. Even worse, you might deliver an incorrect or buggy version to your customers. There goes your reputation, right? It's also about basic security. It ensures reliable storage so you don't simply forget where the source code for a specific version is saved. Furthermore, if you look at modern agile development, where components and systems are changed several times a single day, that is practically impossible without using CM tools. Modern, fast-paced software engineering relies entirely on this foundation to function. Moving right along to Section 2, the 4 core activities.
Now that we know why CM is the backbone of software engineering, let's examine the 4 core pillars, or activities, that make up the entire configuration management process. Take a look at this diagram. This interconnected web brilliantly illustrates the landscape of CM. You can follow the arrows and see how component versions feed into version management, how system building creates system versions, and how change management acts as this sort of central hub, dealing with change proposals and feeding into system releases. It's all connected.
Let's slowly unpack each of these 4 steps, because this is a really crucial concept. First, we have version control. This involves keeping track of the multiple versions of system components. It's how we ensure that changes made by different developers do not interfere with each other. It's exactly how we minimize those accidental overwrites we talked about earlier. Second is system building. This is the actual physical process of assembling program components, data, and libraries, and then compiling and linking them to create a final executable system. Third, we have change management. This involves keeping track of requests for changes to delivered software from both customers and developers, working out the costs, and deciding if and when to actually implement them. And fourth, release management. This is preparing the software for external release and keeping track of the system versions that are already out there in the wild.
Which brings us to Section 3, Phases of System Development.
Now that we understand those 4 core activities, we really need to contextualize them in the real-world phases of system development. Software generally lives its life across 3 distinct phases. Phase 1 is the development phase. This is where the development team is actively creating the software, changing components, and adding new features. It's the highly creative phase. Phase 2 is the system testing phase. Now, I want to point out a very common student misconception here, so please pay attention. During the system testing phase, absolutely no new features are added. 0. The focus is entirely on finding and fixing bugs, performance issues, and vulnerabilities. Finally, Phase 3 is the release phase. The software is finally in the customer's hands, and this is where we start generating new change requests and bug reports from actual, real-world users.
Now, what's really interesting about this multi-version reality is that it completely shatters the illusion that software development is just a simple, single straight line. For large systems, there is literally never just one single working version. As you can see in this diagram, you have different versions progressing simultaneously. Older versions branch off to become releases, while the main development continues on entirely new versions at the exact same time.
Let's use a specific example straight from the textbook to solidify this concept. Look at how a team manages multiple timelines. Let's say version 1.5 of the system might currently be receiving bug fixes and performance improvements to support an existing release. But at the exact same time, a completely different team might be putting version 2.4 through rigorous system testing to prepare for a major release 2.0. Configuration management is the magic that allows these parallel timelines to exist without developers overriding each other's work or accidentally introducing shiny new version 2.4 features into a critical version 1.5 bug fix. Understanding this complex multi-version reality leads us directly into our next topic.
Section 4. Essential CM Terminology. Let's get into the vocabulary. Now, I will completely acknowledge that CM terminology can be quite dense. You look at a table like this and see terms like code line, configuration item, and merging, and it can feel a bit overwhelming. But don't worry. While they are all important, for the sake of our exam focus today, we are going to isolate and define the 4 most critical terms that you absolutely must recognize and have memorized. The first critical term is baseline. A baseline is a controlled collection of component versions that make up a system. Now, I need you to write this down, highlight it, and underline it. Component versions used in a baseline cannot be changed, ever. Once a baseline is established, it is locked down. If you need to make a change, you don't alter the baseline. Rather, you create a brand new version of the component. Because it is a fixed historical record, it is always possible to perfectly recreate a baseline from its constituent components.
Next up is branching. Branching is the creation of a new code line from a version in an existing code line. Think of it in really simple terms. It is a safe sandbox to experiment in. If you need to fix a nasty bug or try developing a risky new feature, you create a branch. This allows you to develop entirely independently without breaking the mainline code that everyone else on your team is currently relying on.
Our third essential term is repository. The repository is essentially the central source of truth for the entire development team. It is a shared database that stores all the different versions of software components, as well as the meta-information. And by meta-information, I just mean the data about the changes made to those components, like exactly who made the change, when they made it, and why.
Finally, we have the workspace. You can contrast the workspace directly with the shared repository we just talked about. The workspace is a private work area on a developer's own machine. This is where you actually sit down to write and modify your code. By keeping your work in a private workspace until it's finished and tested, you protect the wider team and that shared repository from half-finished code and sudden, unexpected breakages. Now, just to ensure we have complete textbook coverage today, I also want to briefly mention CM standards. Formal standards, such as IEEE 828/2012, exist to guide CM processes, and they heavily focus on the formal documents produced during the process. However, you should recognize the tension here. While large traditional organizations or defense contractors might use these external standards for quality certification, fast-paced agile methods rarely use them. The documentation overhead required by formal standards is simply way too heavy for an agile team that needs to prioritize rapid daily changes. Okay, with that complete picture in mind, let's consolidate everything we've learned.
Our final stop, Section 5, Summary and Exam Review.
Let's recap the highly testable key facts, and I'll go slowly to make sure you are fully prepared for your assessments. First, remember the fundamental why. Configuration management prevents code loss and chaos in evolving systems. Second, you must know the 4 core activities by heart. That's version control, system building, change management, and release management. Third, be able to explain the 3 development phases: development, system testing, and release. And remember, system testing means no new features. Lastly, remember the strict definition of a baseline. It is a controlled collection that absolutely cannot be changed. These points are highly likely to appear in your tests and exams, so definitely prioritize them in your studying.
While you've done a brilliant job grasping the introduction to configuration management today, but this naturally leads us to a pretty fascinating question for our next session. If version management is so crucial to preventing team chaos, how do we actually pull it off technically?
Up next, we will take a deep dive into version management. We'll explore the critical differences between older centralized repositories and modern distributed systems like Git. How exactly do they manage the complex behavior of thousands of daily code commits without breaking a sweat? I really look forward to exploring that with you in our next explainer. Until then, keep studying, and I'll see you next time.